New Minds presents
The Steam Train! Hello everybody and welcome back to The Steam Train, the super awesome New Mind show where Dorian, Toby, and all sorts of different characters get up to shenanigans and learn a lot along the way. I hope you guys enjoy. Let's go ahead and see what happened earlier in this episode. Oh, hey Toby, what game are you playing? I'm playing Tetris. Tetris, you mean like the math game? Okay, Toby, so you want to know where Tetris pieces get their name. It actually involves math, and there's something in math called a polyomino. A polyomino is a special shape made out of equal-sized squares. So we're going to go through and we're going to see some polyominoes. The first is a monomino. We're going to take one square and place it on our background. How many different ways can the square sit? One, right? If we turn it, it's still the same square. If we flip it over, it's still the same square. And no matter what, this is the same piece. So let's see if we can add more to this and make it a little bit better. Now we have two blocks. It's no longer a monomino, it's a domino. The do part of domino just means two. And you've probably heard the word domino before because you've seen one of these. You notice a domino is the same shape. There's only one way a domino can be. Even if we rotate it or flip it, it's still the same shape. So a monomino and a domino both only have one combination. Let's do a third piece. This is one way you can make a trimino or a three-pieced polyomino. But maybe you do something like this. So we actually have two different combinations. Now this one, if we were to move the block anywhere else, it would just be the same piece but rotated, so we don't count it. And the same thing goes for the line. If we built it vertically, it's the same shape. But we're going to go ahead to one you're going to recognize a lot more, the tetramino. I went ahead and built all of the tetraminos that you see in Tetris. In Tetris, there's 7 pieces. Now they're called tetraminos because the tetra means 4. You'll see that each one of these is made out of 4 even squares. 1, 2, 3, 4. Now that you see that they're all the same, I'm actually going to take away 2 of these blocks. One of them right here is just a reflection of this one, and this one is just a reflection of the one next to it. So I'm actually going to take these off. But a tetramino is an arrangement of 4 blocks. There's actually 5 combinations. So our monominos had 1, our dominoes had 1, our triminos had 2, and our tetraminos have 5 combinations without reflections. Now, Toby, you're going to go ahead and go back and play your game. Woohoo! While we look at pentominoes, I'm actually going to give you our first challenge for today. Let me move these out of the way. Take 5 squares of any color and take a backboard. I have red. They don't all have to be the same color. I want you to see how many pentominoes you can come up with before I show you how to make them. Remember, pentominoes are 5 squares. If they are reflected or rotated, then it does not count. If I rotate this, it does not make it a new shape. Same thing with this one. If I just rotate it, it's still the same shape, so it doesn't count. I've only made 2 so far. I want to see how many you can make before I show you how to make them. We're going to make a really cool set that's used for a lot of puzzles and a lot of cool things. So stick around, but first, I want you to pause the video here, see how many you can make. And we're back. There's actually 12 combinations you can make out of pentominoes. If you count versions that are reflected, for example, if I reflected this in a mirror and it made the same shape but the other direction, there would be 18. There are 6 that actually reflect. But did you figure out all 12 pentominoes? If not, it's okay. We're actually going to start our big project for today, and you're going to get to see all of them, and you're going to use them to make your own puzzles, and they're pretty cool to use. And we're going to look at our supplies we need for this project. It's pretty simple. You're going to need some scissors, something dark to write with, a piece of graph paper. If you don't have graph paper, you can draw the lines on yourself using a ruler, but this is going to make it a lot easier. And of course, something to add color with so all of our pieces look different. The way I'm going to make these is going to be pretty compact, so follow along. I'm going to go pretty slow, and I'm actually going to hold it up to the screen so you can pause it when you need to. But what we're going to do is we're going to make our own box, and we're going to cut this into puzzle pieces. Our box is going to be 6 by 10 squares. I'm going to double it because I want extra big pieces. So I'm going to mark a corner towards the corner of the page. I'm going to count over 20 squares because I'm doubling 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Perfect. And I'm going to mark this as my corner. And I need to go down 12 because it is 6 and I'm doubling it. You can do it regular size too. Your pieces are just going to be kind of small. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You notice when I'm doubling it, I'm only marking every other square. So go ahead and make your grid. In your grid, just go ahead and line them up. But I'm going to go ahead and make my lines all the way across. I should have 6 lines going one way, 10 lines going the other way. I'm going to hold this up to the camera, pause it if you need to. This is going to take a while, so I'm not going to do it on camera. And this is what our finished grid will look like. It is 6 squares down and 12 squares across. Go ahead and pause it here and make sure you catch up. The next parts are going to be pretty quick. It's going to help us get all of our pieces laid out, and then we can color them in and cut them out and have our awesome puzzle. Go ahead and set this down and get out some colors. We're making 12 pieces, so you will need at least 12 colors, or you can make them different patterns such as polka dots and stripes, or you can just alternate them just enough so you can tell apart which piece goes where. If you want to make this, pause here. Make these same shapes, and then we're going to cut them out. Now this whole grid is 6 by 10, so it actually makes 60 squares. 6 times 10 is 60. 60 is a number with a lot of factors. Maybe we can make it in a grid that's 4 by 15, or maybe 5 by 12, maybe even 3 by 20. So when you cut these apart, we're going to try and see if we could fit it in those different shapes. Of course, before we do any other rearranging, we're going to cut these out. Make sure you cut each piece together, don't cut the pieces apart. So this piece, cut around the black piece altogether, and that's why we colored them the way we did. And now you should have all 12 of your pieces cut out. Now that they're cut out, your first challenge is see if you can put them back in their original 6 by 10 grid that it started with. When you do that, see if you can fit them in a 4 by 15, 5 by 12, and a 3 by 20. I'll go ahead and show you the solutions for those so you can pause it if you want to see those. I'll show them really briefly. Then we're going to talk about where we see these in real life puzzles, and we're going to talk about bigger numbers. Here's the solution for the 6 by 10 version of the puzzle. Here's the solution to the 5 by 12 version of the puzzle. You notice that some pieces are flipped over. You can turn the pieces backwards if you need to solve it. Here's the solution to the 4 by 15 version of the puzzle. Lastly, here's the solution to the 3 by 20 version of the puzzle. Now, I've always loved these puzzles, and they've been really cool to me. I used to collect puzzles when I was younger. But there was one puzzle I could never solve, and later in life I figured out it is actually a Pentomino puzzle. And it is this pineapple puzzle. Now this looks like a pineapple in a jar. When you take it apart, they're actually different pieces. I realized that these pieces are actually our Pentominoes, and I'll show you how. So let me go ahead and dump them out. You'll see that we have all sorts of different shapes. But when you look at them, you start to realize some are familiar. This U shape is the same as our U pentomino. There's a plus that's the same as our plus pentomino. This piece looks very, very similar to this piece. This piece. And as you sort them out, you start to realize the straight line is just this half curve. This weird looking one is actually just this piece flipped upside down. And I saw the similarities in the puzzles and how my pentominoes worked. And then I was finally able to figure out the puzzle that's given me troubles for a couple years. So sometimes familiar math is used in more places than you looked. I actually wrote this solution as a kid, and this is how I figured out where all the pieces went. And that's when I realized it was pentominoes, was I drew each shape as a piece, it makes a spiral, and then that spiral fits in the jar. And I can't wait to see you guys try and solve this puzzle, or maybe what unique shapes you can use your pentominoes to make. And let's go ahead and see how Toby's been doing on his Tetris game. Thank you guys for tuning in with another real inspired learning with new minds. And also another amazing episode of the STEAM Train. I hope you guys have enjoyed, and if you like the video down below. If you have an idea what we should do next, leave a comment. And if you want to catch all of our awesome New Minds content, don't forget to subscribe. Thank you guys all very much for watching, and have a wonderful rest of your day. Here's an outro.